everyone, my name is Christine. I graduated from University of Maryland's Fire Protection Engineering program with my bachelor's in 2013 and my master's in 2014. And I am currently a fire engineering consultant at Arup in our London office. This summer, I had the privilege to work on a project very unique to Arup. This year marks the 350-year anniversary of the Great Fire of London, which occurred in September of 1666. The fire started in a bakery in Pudding Lane, and it spread rapidly for 4 days, destroying over 13,000 homes and displacing up to 70,000 people. At the end of those 4 days, only 20% of the city was left intact.
To commemorate the event and highlight the rebirth of the city and fire safety principles that emerged following this tragedy, London will host a series of events in the city. One which will include burning a 120-meter-long timber model of 17th century London in the middle of the Thames River this September. Arup has been commissioned to provide the fire and environmental advice prior to the event, and I am very fortunate to be assisting our team.
This project has truly been one of a kind, using our understanding of fire and smoke dynamics to anticipate the many what-ifs. You know a project truly stems from its first principles when your project director brings in these drawings that his young children drew to get us to consider the many outcomes of the burning barge. So some of which include radiation, so the radiation of the barge onto the people and to the fire brigade on the water. Also the smoke impact to people and also to the environment. We also considered the possibility of burning brands, so the timber burning off and affecting the rest of London and also on the Thames, the fire brigade. We also considered the uncontrolled fire, so if the entire barge is burning, the effect of the steel barge itself, and also the possibility of a firewall, which is a definite possibility given the cityscape of London.
During this process, we attended numerous site visits to the building of the barge and witnessed fire testing held by the event's pyrotechnic fire starters, we'll call them. This helped us anticipate the possible fire spread and to quantify the combustible material proposed for the event to best anticipate the worst-case fire scenarios.
Hi everyone, it's D-Day. There are thousands of people here.
Ultimately, our final analysis included advising on the potential smoke quality and concentration with help of Arup's environmental planning team, calculating heat transfer through the barge, which was protected by granite ballast, using a 1D conduction heat transfer analysis method. We also advised on safe distances on the Thames from the barge in a worst-case scenario, given potential radiation from an uncontrolled fire. Our analysis also included researching firebrand generation and transport from timber and using a software called Behave Plus developed by USDA Forest Service to anticipate possible travel distances of firebrands. A special thank you to Dr. Michael Golner from the University of Maryland for advising us on this one, and to Catherine, who was our fire engineering intern in London this summer, who is currently a junior in Maryland's FPE program.
That was the scariest thing ever. They're putting it out now. Success!
Thank you to Arup Fire for the incredible opportunity to help safely commemorate the past and highlight the advancements of our thoughtful work as engineers in the fire field. And thank you to the FPE program at UMD for facilitating my education and instilling my passion for fire engineering.